So my name is Pravin Barton. I'm a software developer here at the Application Services team at InterSystems. So most of my work is on our internal business applications, you know, the boring stuff that helps our business run, helps our customers, helps our employees. But I also get to contribute to some of our open source initiatives that our team has. So today I'm here to show you how to embed source control using Git into your Iris development workflow. So some quick points we're going to hit today. First off, why use source control at all? Some very basic background for software developers. Second, some of the unique things about using source control in Iris for development. And third, I'll go over the key features of our project, Git Source Control. And then I'm going to propose and demonstrate a sample workflow using Git Source Control to make changes and deploy them. All right, who's here? Probably a mix of all of these. Maybe you're not using source control at all in your systems, but you know you should be, so you want to change that. Maybe you are using source control, but you want to improve the developer experience some. Or you just want to mix things up. You're a little bored with your existing stuff. Or third, maybe you're already using Git. Maybe you're already using Git Source Control, our project, and you want to know what the latest developments are, because we've presented this in the past summits before. So first off, the big basics. Why use source control at all? Source control is essential whenever you're working with any sort of code. First of all, you always want to keep track of the history of changes to all of your code, and this is going to save you a ton of headaches to a developer, as a developer. And then second, as soon as you have more than one person working on your code base, which you probably are, you need some way to merge people's changes together so they don't like fight, they don't overwrite each other. Source control systems have some useful tools for doing that. And then third, if you're going to deploy your code to some remote environment so people can actually log in and use your system, you're going to need some way to keep track of which changes you're deploying. So there are all sorts of deployment models. Maybe you're cutting a release every so often with a bunch of changes. Maybe you're like continuously deploying. Whenever a change is merged, it goes directly to production. But either way, the basis of your deployment strategy is probably going to be source control nowadays. All right, so how is source control different in Iris? Let me tell you the basic story that you learn about source control when you're learning how to program. You're editing a bunch of files in a directory. You go into that directory and run git init, or whatever command there is for your source control system. And from there on, you're golden. You can do source control operations as needed in the command line in that directory. That story doesn't always apply. And it doesn't apply in Iris because code doesn't live in flat files. It lives inside of the database. And you can't really source control a database with Git. So traditionally, you edit your code directly in the database as well, using our custom IDE, which is called Studio. You're probably familiar with it. And this is a model we call server-side editing. More recently, we've moved towards a VS Code extension for our editing experience. So that supports the more traditional like client-side editing, where you have a directory of files and you're editing files there. And then our extension will like push them to the Iris database when you save. But it does also support server-side editing, identical to how Studio did it, or very similar to how Studio did it. And you're going to need that if you're doing collaborative editing of a shared development environment. I'll get into that a little bit more later. And then there's a third way you could be writing code. And this is when you're using the code builder UIs in the management portal. So the management portal has all sorts of graphical user interfaces that let you graphically build code by dragging and dropping little boxes or like clicking, putting in text boxes. You saw that if you were in the keynotes this morning with the rule editor. So if you're using these portal editors, that's also going to be server-side editing. Some examples of that are if you're using Iris Business Intelligence, you're defining a cube in the management portal, or a dashboard, or a pivot, or something like that. And then the other big one is interoperability. So business processes, business rules, that sort of thing. Lookup tables, yeah, that's all in the portal. Source code in the database, that sounds a little strange, but I'll just give a brief sidebar. This is pretty common when you're developing in databases. Think about your life as an SQL developer. You're writing a bunch of SQL statements that create tables, that create views or procedures. You run them, and it creates these items in the database. So the schema lives in the database. How does it get to source control? Normally, the story is you have to export it from the database using some other tool. Something about Iris that our team really likes is that if you do run one of these create table statements, it'll automatically generate the object script class code, which encodes that table or view or procedure. And then you can edit it as object script class code as normal. So that's really nice, but it still leaves that problem of you need something else to map that item in the database to a file in your source control repository. So what is that something else? It's called a Studio Source Control extension. These are the conduit between Iris and the source control system of your choice. They play a couple of important roles. First, they map code or config items in the database to files on the file system inside of your source control repository. They hook into your editor, whether it's Studio, VS Code, or the system management portal, so that when you save a document, it'll automatically get exported to the right place in your Git or other repository. And then second, they provide a user interface for all the basic source control operations, like adding a file to source control or committing a change. That user interface is also going to be embedded into the editor of your choice, whether that's Studio or VS Code. Where do you get one of these Studio source control extensions? So if you're using Perforce for source control, we have one of them built into the product, so you could use that. If you're using something else, there are a number of extensions that people have. You can get them on the Open Exchange or buy them from a vendor. A third option is you can build your own. This is kind of a heavy lift, but we have it pretty well documented. So you can build one that fits the needs of your organization. And then a fourth one is the one I'm going to focus on today, which is Git Source Control. So Git Source Control is an open source project primarily maintained by the application services team within InterSystems. And especially I want to give a shout out to Tim Levitt, who's the development manager, but also a great coder and architect who's put in a lot of work to it. So Git Source Control is a tool, it's an extension that provides a fully embedded source control experience using Git in Iris. So now I'm going to give a quick tour through each of the key features of Git Source Control. The first part of source control extensions that you expect is to synchronize those documents in the database with the files in your source control repository. So Git Source Control provides a default mapping of document types to subdirectories. So for example, classes go into the CLS directory. This is a UI showing the defaults, but you can also add your own. Using a mapping schema. So for example, you see here the unit test package. We map that to a different directory. That's part of the defaults called test. You probably want your unit tests in a different directory than the rest of your code because you don't want to deploy those. Git Source Control also comes packaged with a graphical user interface, a web user interface that does most of the basic source control operations in Git. So you can use this to add or remove files. You can commit changes. You can push and pull to remotes. You can create branches. And you can even stash changes and then pop them from the stash when you need them back. Why use this UI rather than just the Git command line that you might be used to? I think the main audience for this is going to be shared development environments. So before I get into shared development environments, I want to describe the worst case and the best case scenario for Iris development. So the worst case scenario is there's one environment, it's shared, and it's called production. All of our developers just log into production and they edit code directly in production, compile, our users immediately see the changes. It's really simple, right? But I don't need to explain why that's going to be problematic. Now the best case scenario is that there's a script that any developer can run to quickly and simply spin up a development environment that just lives in their laptop. Or maybe it's on the cloud, something like that. It doesn't really matter. And that makes it really simple to create your own development environment so your changes won't conflict with somebody else's. Now there's the medium case, which is a shared development environment. And you have a separate development environment, maybe one namespace on an Iris instance somewhere, which a bunch of different developers are connecting to and editing code directly. That can be simpler than scripting local development environments in a lot of cases. So what do you need to support this case of a shared development environment? First thing is some sort of concurrency management. If I need a change for a file, if I need a file for my feature that I'm implementing, I don't want other people to be editing that file at the same time. So I need some way to lock it. Git by itself doesn't support this. It was never intended for this use. So Git Source Control adds a concurrency layer on top of Git that prohibits you from editing a change that somebody else has changed. Second, you need some way to deal with file permissions. So source control systems usually don't play well with a bunch of files in your repository being owned by different people. Kind of an unwritten rule of Studio source control extensions is that all of the files in your repository should be owned by the operating user of the Iris instance. So on a Unix system, that'll be Iris user. On Windows, that'll be probably system or a special account that you've defined. And if the files are owned by individual people, that can lead to problems. Git Source Control solves this problem with that web UI from before. When you make Git operations from that web UI, they run at the operating system level as the operating user for the instance. It still keeps track of who's making changes and stuff like that because it maps your Iris username to a Git attribution. It stores some configuration against your specific Iris account. All right, now we're getting out of the realm of source control a little and into the realm of deployment. Pull event handlers let you define some actions to take place after you've pulled code from a Git remote repository to an Iris environment. Typically, you want to compile the code that you've pulled so it's actually deployed to the environment. There's a couple options for pull event handlers built into Git source control. The first one is incremental load, and that'll just load and compile those specific files that have been changed as part of the pull. The second one is a package manager strategy, and that'll do a ZPM load if your application is using the package manager. If you use the package manager, you know what that means. If you don't have to worry about it. By default, Git source control will see if your application is using the package manager. If so, it does that ZPM load. If not, it'll do the incremental load. And then you can also define your own custom pull event handler if there's some configuration task you want to have happen when you pull some code. So for example, maybe you've changed a business process. You want to restart that item so the changes actually apply in your interoperability production. All right. At this point, I'm going to propose and then demo my sample workflow for developing code using Git source control. The goal of this workflow is to demonstrate features of Git source control that you can pick and choose for your own needs. So for this workflow, I want to show how you can develop in a private environment running in a container. I want to make it really easy for a new developer to start out making changes to a system, and I think containers are a really great way to do that. I also want a couple of shared environments. One of them, of course, is production, but I also want a shared staging or pre-production environment. And that's going to have a couple of benefits. First, it'll allow me to do some additional testing on a shared environment that might have some more data and more interoperability connections set up. And second, it's also going to let me test my deployment process as part of the change. So I deploy to a pre-production environment before I actually deploy to my production. Now, speaking of deployment, I want to click a button to deploy manually. For this workflow, I don't want to get fancy with some continuous deployment or webhooks or something like that. I want to keep it really simple. And then finally, I want this workflow to be adaptable to any Git flow. There are a bunch of different ones, and each team is going to have their own different preferences. So here's a diagram of the Git workflow I'm going to use for the demo. There's 2 shared environments. One is for staging, it's that pre-production environment, and the other is production. There are also 2 permanent branches, our main branch and our production branch. For this demo, they're going to be hosted on a GitHub remote repository. When I'm developing a feature, I create a feature branch. This is a very common flow for Git. And I'm going to check in changes from my development container to that feature branch. Then from the feature branch, I merge to main, and I can deploy it to my pre-production environment. Once it's gone through some review, I'm ready to go live. I merge it to my separate production branch. And then I deploy from the production branch to the production environment. All right. At this point, I'm going to actually try to live demo it. So think good thoughts. Is it showing my screen? Yeah. Oh, I can see it down there. Perfect. Sorry, just a second as I figure out the... There we go. Hold on. Where am I? So I'm a new developer on my team. I just got hired, and I got assigned a first feature. And I'm going to be making that on this project. It's called Summit Sample Git. The first thing I do whenever I want to start making changes to a new project is a git clone. So I go into my projects directory, and can I make this bigger? I probably can, right? There we go. That's as big as it's going to get, but hopefully that's good enough. I do this git clone command. That succeeds. Now I'm going to go into the directory and open VS Code. There's a couple more steps to setting up my environment. I'm going to start one off now because it takes a minute. That's going to be this docker compose build command. And at this point, I can give you a little tour while we're waiting for this to finish. This is Summit Sample Git. It's a very simple project that's forked off of the Iris interoperability template with just a couple changes. So you can see that on our InterSystems GitHub page, Iris interoperability template. It's a very good template to start off with if you're making an Iris interoperability production. And it has a handy Docker file and Docker compose script. First, I'm going to go to the README and show you. This is going to have a section that tells me how to install a development environment. Installation Docker. So git clone, I already did that. Docker compose build, I already did that. One more command, docker compose up, which will actually bring up my environment. All right, I'm going to give you a little more of a tour through here. So I mentioned the Docker compose. This is a very simple way of defining what Docker containers you want to be part of your project. Here it's just one Iris container, very simple. And we have a volume mounted. So this is the current repository. All of this, where our code lives, is mounted inside of the container at this directory, home, Iris owner, Iris dev. That's the only important thing here that I want to show. Then we have a Docker file. It's just based on our Iris community image. And it runs a specific Iris script. And these are some object script commands. The things I want to show are, let me see if I can zoom this too. Yeah. we're doing a ZPM load command to install Git Source Control, which is that project I've been talking about, and I've been saying those 3 syllables a lot. So it's loading it directly from GitHub. It has the URL there, so that'll get the latest and greatest. You probably don't want to do that. You probably want to pin a specific released version from the ZPM repository. And at the very end, it does a ZPM load that installs this whole directory. All right. Just a second now as I pull up. Go back here, and we see our Docker compose up has finished. That means the container is up and running. I have an Iris instance running on my laptop. This is a lot quicker than if I had to install it from scratch, right? The next step I want to do is actually go into the container and configure Git Source Control. I'm in an Iris terminal inside of the container now, and I'm going to run a command from Git Source Control that lets me set up some configuration. These are things I could be automating as part of my Docker file, as part of that Iris script, but I wanted to show you, so I'm doing it manually. Ah, man, forgot one of these guys, thank you. All right, for a lot of these, I'm going to go with the defaults. It's looking for a Git executable inside of the container. It knows where it is. And now it wants where my Git repo is. So remember when I showed you the Docker file, it was mounting that this directory inside the container at a specific directory. And I'm going to put that in here. And now it wants a path to a private key file. So it's going to create an SSH key for me, which is going to allow me to push code from this repository to my remote, to GitHub. So I'm going to put it inside of that same mapped directory. And that means it's mapped outside of the container too, so it'll persist if I take down the container. Home Iris owner, Iris dev, SSH. Yeah, there we go. Default event handler class. Defaults for the rest, and I'll put in my attribution details here. And here it's going to create that key pair. This is the public key. I hope there are no hackers in the audience. In order to use that public key with GitHub, I'll need to go back to my repository and set it up as a deploy key. So to do that, I go to my repository settings, down to deploy keys, delete the old one that I created when I was practicing this, and add a new one. This one is going to be called pbarton dev container, because it's only going to be used by me from my development container. And importantly, I want to check this box so I can write changes from inside of the container to the GitHub repository. Add key, and we are good. So we're done with our setup. Now I want to actually make a change. First thing I do when I want to make a change is create a branch for my feature. I can do that from the Git Source Control UI. This is the system management portal for my container. So all of the things I'm showing you from the web UI, you can also just do from the command line. I'm just going to prove that to you really quickly. You could run a git status. You can run all your git commands in that terminal. I just want to use the web UI here so I can show it off. Am I running out of time? No. So I create a new branch for my feature. And my feature is going to be changing the email for a dog. This is something I do often as a developer. Dogs come to me and ask for their emails to be changed. And hey, I created that branch and switched to it. I'm going to prove that again for the skeptics in the audience. On branch change dog email. Now I can start making a change. I'm going to make a change using one of those code builder UIs. And this is going to be the rule editor. Build business rules. Just to give you some context, this is the interoperability template. Basically what it does is it scrapes Reddits for pictures, and it sees if they're dogs or cats. And if it's a dog, it emails it to a dog, and the dog logs onto his email address, opens up the email and looks at the picture of the dog, and starts barking. If it's a cat, I guess it'll meow. I don't know what cats do, really. But anyway, the change I want to make is to the dog's email address. The dog is grown up a little bit. It wants a more mature professional email address, so it's changed to dog from doggo. All right, we've made a change. I'm going to compile it. Okay, I'm happy with my change. I want to check it in. So if you're not familiar with Git, there are kind of 3 stages to checking in a change with Git. I recognize check-in is not the right Git terminology. But anyway, we should see our change here. And it's not yet staged. I can use the UI to view the diffs and confirm it's what I want. So my first step is going to be to stage it. That'll add it to the staging area. From there, I'm going to commit it with a nice commit message. Changed the dog's email, as one does, and commit. That's the second step. Third step is to push it to that remote repository, our GitHub thing. And I can do that through the Git UI here. There's a push to remote branch option. It doesn't really give me much feedback, but I can open up this dialog, source control messages, and I see a message. That's what I expect from a Git push. It's giving me a warning about something. I don't really care. All right. At this point, I've made my change, and I want to get it ready for review from my other developers on my team. To do that, I'm going to make a pull request. Basically, I'm asking nicely, can I please merge this into the main? So in GitHub, I make a pull request here. The base is going to be main, and compare is going to be my feature branch. Here we see that diff that we expect, so I'm going to create the pull request. At this point, the rest of the developers on my team are going to log in. They're going to look at the diff, and they're going to give me the thumbs up because my code is always flawless. They always pass my reviews. I'm going to assume they've done that so far, and I'm going to confirm the merge. All right, it's merged into main, so I can delete my feature branch. Now, remember, from main, we deploy to our pre-production environment. And we want to do that at the click of a button. We want to do it manually. So I'm going to also do that from the Git Source Control UI. Our staging and production environments here are just running on my local Iris instance because it's a demo. But you'll notice on our favorites page, there are a bunch of favorites that are automatically added when we installed Git Source Control. And one of them is the Git pull page. Let me zoom in a bit. And we'll see we have a preview of files that will be modified if we pull the latest. That's what I expect. So I'm going to click that button. We've pulled it. And now our pull event handler is going to run. We're using the package manager, so it's going to do a ZPM load and recompile everything. And I see a bunch of successes, and that always makes me happy. But just to double check, I'm going to go into the rule editor and do a testing plan on our pre-production environment, which is just open up that rule and see that the dog's email is what the dog wants it to be. And there we go. All right, now it's time for another pull request. We've tested it in our staging environment, and we're ready to go live with all of the changes from our staging environment. So I'm going to go back to my GitHub repository. And the process is going to be exactly the same as before. Create a new pull request. This time the base is going to be production instead of main. And now we see that diff from main to production. It's what we expect. I create a pull request. All right. Again, my coworkers are going to go in and check my work because they don't trust me. I think they have a darkness in their soul. They don't believe when I tell them my code has no bugs. There's something wrong with them. But I work with it. It's okay. I'm not mad. And at this stage, they can do something else. They can actually log into that shared pre-production environment again. And they can test my changes against actual data in that test environment. And that's nice because it's another level of testing more than just looking at the code. So they've gone in here, and they've seen that I'm perfect as always. They did their reviews, and now I'm going to confirm a merge. All right, there's one more deployment, which is our go live. Maybe I do this right after the merge. Maybe we have a deploy window where we do all of our deploys on Friday evening, right before our least favorite coworker is on pager duty. But either way, you see how deploy is kind of separated from the merge because we're deploying manually. I'm going to go to that git pull page, this time for my live environment. And it sees changes that are modified. That's what I expect. Click a button to pull. It does the same thing. Oh no. This is the problem with the live demos. They always fail unexpectedly. I know how to fix this one though. If it takes me less than a minute to fix it, I'll do it. Otherwise, I'll just give up. It's saying there's a change already on my live environment. So I'm going to go to the web UI there and just stash that change. Let's try again. Go back to our git pull. This is live, right? Yeah, this is our production environment. And I'm going to click the button a second time. I think it's going to work. Yeah, I see my successes again. And I'm going to prove again that the change actually deployed just by opening up the code here. Yeah, that's the email we expect in the code. And it's live, so the dog is now getting the emails they expect. There's our demo. Oh man, are we going to be able to get the slideshow back? Yeah, there we go. All right, in summary, a couple of key takeaways I want you to take away from this. That was redundant, but anyway. First, source control in Iris can't be taken for granted. if you're developing Iris, you need a source control strategy. And I hope I've convinced you that Git Source Control, this project, is one good option for using Git. I hope I've also demonstrated a complete development and deployment workflow using Git Source Control that could be feasible for actual developers in an actual organization. And finally, I'd like you to check it out. You can go to GitHub here, see the repository for Git Source Control, and try it out in your own systems if you want. And if you have any questions about Git Source Control, if you have any feature requests, just complaints, rants about the state of the world, I encourage you to email my manager, Tim Levitt. And if you have any cute photos of dogs or cats, you can email me, pravin.barton@intersystems.com. All right, thank you so much. All right, I have a little time for questions or, I don't know, comments. Do we have somebody with a microphone? Yes, thank you.
Is it on? Yeah.
Yes.
So you've shown that someone edited the rule, and then they had to go through the Git menu to export that change into a file, or was it done automatically every time?
That's done automatically.
Okay.
When the configure command configured Git Source Control as a source control extension, and then every time you edit that rule through this SMP, it's going to automatically export to the file. So.
And is there a way to have kind of a notification or alert if someone changed something and does not commit the change?
Yeah, so if it's a shared environment and you go to that rule and somebody else has edited it, I can't remember off the top of my head what happens. Either it'll just give you a big red alert, like somebody else has changed this, you cannot edit it. Or maybe it's just a warning, so you can kind of steal their change if they've gone off on a flight to the Bahamas, something like that. Yeah.
Two questions. I guess the first one, when you deployed and it showed the diff, was it doing a diff against a Git file on the remote system or against the Iris database? How was it doing diff?
That would be a diff against the local Git repository. So there's a Git repository on the OS that this Iris instance is running on, and it'll pull to that file and then load from the directory.
So in a deployment situation, I was talking about the remote. So I guess in your demo it was local, but I mean.
Right. Yep. It would be on the remote server.
Yeah, okay.
Right, sorry.
And are there any changes you can make that would not be tracked? You know, productions or properties?
Yeah, that's a great question. So changes that you would make that are not tracked are changes to items where we don't fully support source control extensions. There's been a lot of improvement. A lot of things that used to not support them now do. For example, like BI dashboards do. But I think some things like lookup tables still are not tracked with source control extensions. There's a bunch of issues on the backlog, and we'll steadily kind of churn through, like make sure it's integrating well with source control.
Maybe the third question, the locking that I guess he was talking about as well. Can you just describe how that works? Is it, do you specify that you want to lock a class, for example? Is it, or is it happen automatically? You never have two open changes at the same time? I guess in your flow, you were working locally and then merging. There really shouldn't be anything open, I guess, on that server, in that flow anyway.
Right. So in that local development workflow, it's not a huge issue. But with shared development, the locking works by when you make a change, it stores in a table of it in the database, like who changed each file. It'll store the Iris username. So There's both the Git diff, which will see what has been changed in the repository, and then a separate table which attributes each of those changes to somebody. Yeah.
Does this only work with GitHub, or does it also work with like Git and other instances of Git?
It'll work with whatever Git development tool you want, like Bitbucket or GitLab, something like that. I was just using GitHub for the demo because it's pretty well known.
When does your code get updated? Is it on Git pull that it gets loaded into the database, or when you open the code?
It's updated on that Git pull. So basically, when you click that button in the Git pull UI, it calls a method in our Git source control extension. And that method both does a Git pull against the operating system and then runs our pull event handler, and that'll compile it.
Well, I'm wondering if this also works with Azure DevOps, or it only works with GitHub. In Azure DevOps,
Sorry, could you repeat that?
is this way to deploy the code and using the code, it's possible to configure it to using Azure DevOps for Microsoft. Because we can, in my company, we can use the GitHub because it's so, our code is we don't want to share our code, and
Right.
it's using the Azure DevOps in the Microsoft. Then we create different environments and different pipelines to deploy. But it's possible to configure that for using that, or only works with Azure, only works with GitHub.
If I'm understanding you correctly, you're asking if it only works with GitHub, or if you can just plug in whatever Git repository you want, whatever Git remote. And it's the latter. You can use whatever Git remote you're using, whether that's GitHub, or maybe you have Bitbucket hosted locally, or you just have some Git remote hosted on a server somewhere in a desk or a closet in your building.
So you mentioned that certain things like lookup tables are not currently supported. But what about things that sit on the file system like CSP assets? Is there any functionality for that?
Great question. So these are things that exist on the file system, but not in the IRIS database. I think for that, there's no built-in support with Git source control or our Studio source control extensions. But if they're just living on the file system, you can work with them with Git. You might want to like copy them into the Git repository.
I have some dog pictures, so I'll send those in a second.
Awesome, thank you.
There's a control panel for each namespace, isn't there? So do you, if say you're not doing a Docker container, you've got a local instance of Iris on your laptop, you could potentially spin up a new namespace to develop in a new area. Is that how that would work?
Yeah, so we do have the configuration works on a namespace basis. We have even something more adaptable, which is if you're using the package manager and you're defining assets in different namespaces, we'll automatically pick that up and say like assets in these namespaces are associated with this Git repository.
Right, okay.
All right, that might be it. Thank you so much for coming. I hope you got something out of it.